Hi guys, welcome to our channel DevNode. So today we are discussing one LeetCode problem, majority element. LeetCode question number 169, and this question is also easy and it belongs to array. So let's see what is the question. So basically, what is question? Given an array nums of size n and return the majority element. Now what is majority element? So it says the majority element is the element that appears more than n by 2 times. Whatever the size of array, its occurrence should be more than n by 2 times. You may assume that the majority element always exists in the array. So question explain us that all whatever the test case they provided, majority element will always be present there. Now let's see the examples. So this is the example. So here 3 2 3, so n is equal to 3, the size of array. Now what is the minimum occurrence of a number should have to meet the requirement of majority element? So it should be n by 2, basically 3 by 2, which is 1.5. And see what it says, more than. So if we round off it 1, so whatever the frequency of number, it should be greater than 1. Basically at least the frequency should be 2, then it will be eligible for our majority element. Now let's see the frequency of 3, 1 and 2. So 3 frequency is 2, 2 frequency is 1. So 1 is not greater than 1, 2 is greater than 1, so 3 is our answer. Now let's discuss the another example. So here now what is the size of an array? So if we see the size of array, 3 plus 3 6 or 7. So here n is equal to 7. Now what is the minimum frequency should we should have? 7 by 2, which is 3.5. So at least 4. So we will consider the number as a majority element if its occurrence is at least 4 or greater than 4. Now let's see. First we have 2. Now let's see what is the frequency of 2. 2 1 2 3 4. Frequency of 3 2 is 4. Now frequency of 1 1 2 3 3. So which is greater than 3.5? 4. So this is our answer for this use case. So this is the thinking, like how, what is the question requirement. Now let's discuss how we code it, how we compare it. So let me erase this. Now let's see what we need. We want the frequency of each number, frequency of each number. Then we will decide, once we got the frequency, then we will decide it is greater than n by 2 or not. So how we calculate the frequency of 2? So what we can do, we take this 2 first, we take this 2 and check its frequency. So 2 frequency right now, what is count is 1. We goes here, count is 2. 1 is not equal to 2, we move ahead. 1 is not equal to 2, we move ahead. 1 is not equal to 2, 2 is equal to 2, so 3, our we increase our count. And here 2 is also equal to 2, so we increase our count. Whatever is our count, 1 2 3 4. So from here we will get our count as 4. Now once we got the count, we will check if count is greater than n by 2, then this is our answer. So we will return the nums of I. If not, then we will continue again. We will go to this index and we will check the occurrence for this index. Same we will do for this. So what is our, how our code will look like? So our code will look like something like this. So first we will start with the index I equal to 0 and I less than n, the size of error, and I plus plus. Now we will take the number. So our number is number equal to nums of I. And what is our count initially what we define? So if we are at here, so at least we have a one count. So because the number is repeat at least once at this moment, so our count is once. Now we will take another pointer and start from here, which is I plus 1, and we will check from these to the end. So how we write? For our end j pointer which start from I plus 1, and j also less than n and j plus plus. Okay, and how we write this loop? So if nums of I if nums of I is equal to nums of j, what we are comparing? We are comparing these index with this element. So this is our static array for first loop, first iteration. So we are comparing all the element with 2, which is this element. So we'll check nums of I equal to nums of j, then we will increase our count plus plus. Once our this loop end, then we will see if whatever the count we get is greater than n by 2, then we will return the answer. We will return what? We will return number. This is our answer, basically nums of I. And if it does not, it will go for this index, then 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 it will go for this index. So at the end we will get our answer. Got it? Now let's discuss what is the time complexity of this solution. So if we see, we are iterating the loop, one loop here which took O of n, which took O of n. This loop will take O of n, and this loop will also take O of n. So our time complexity of O of n into O of n, which is O of n square. And here the space complexity, we are not taking any extra space, so our space complexity is of 1. Got it? So this is the basic brute force approach that we can say. Now let's this how now what we can optimize here further. So you see here our space complexity is of 1, so we do not need to uh, re- optimize it further. But here time complexity of n square, so we are thinking in some way that we will reduce our time complexity. Now what we can do, of n square can be either reduced to of n log n or of n. So we need solution which can be done in either n log n or of n. So now let's go back to our question. Let's see what we can do. So what was it? 2 2 1 comma 1 comma 1 2 comma 2. So what is our requirement here? We need what is our requirement? Our requirement is we need frequency of each element. So we need what is the frequency of 2, what is the frequency of 1, or what is the frequency of x, whatever the number is there. So what is our requirement? We need frequency of each element. We need frequency of each element. So instead of iterating it, we iterate the array and store its frequency. Like first we iterate 2, so we can use mapper, where we can use the mapper here. So we are here at we start iterating from 2. So the 2 it occurs, the frequency is 1. The 2 we will increase the frequency. 1 got increased to 2. 1 it is not present in the mapper, so we will initialize it with 1. Now 1 we will it is already present, we will increase its frequency. Again 1 we will increase its frequency. Now we got 2, 2 is already there, we will increase its frequency. Now again 2 we will increase it. What at the end what we got? We got frequency of 2 is 4, frequency of 1 is 3. Now what we got this mapper. Now what we do, we will iterate this mapper and check the frequency of each word. If it is greater than n by 2, that is our answer. Now what we will do, we will iterate it. So how we iterate it? For auto it, whatever our mapper, what is its first element? It's a map. So its first it dot first is our number. Okay, so int what is number? it dot first is our number, it dot first is our number, and int frequency equal to it dot second. Now we will check if frequency is greater than n by 2, then we will return the number here, else we will continue. And as the question mentioned, always we have a majority element, so you will every time you will find an element whose frequency is greater than n by 2. If answer says it might be possibility in there's no majority element is present in the given array, then at the end after this we will return minus 1. So if it is present, it will return any number which is the answer, otherwise it will return minus 1. But for this question this is not required, because question explicitly say that majority element is always be present. Now let's discuss its time complexity. Now what we did, first we will iterate this array. So iterating took of n. So this is for the storing the frequency. Now for the mapper, we will also iterate the mapper as well. So what is the frequency of mapper? Frequency of mapper is of k, which is like all the, what is k? All the distinct number. But our question says majority element will always be present. So this is always be less than n by 2. It always less than by 2, because one integer will take n by 2. So if one is there, it will take n by 2. Then rest, if all of them are different, then rest will take n by 2. So here our time complexity is O of n by 2. Now O of n to iterate the array, O of 1 to iterate array, plus O of n by 2 to iterate mapper. Iterate mapper. So what is overall our time complexity? O of n. See, this is the time complexity of this solution. And remember, we also use mapper. So what is the space complexity of mapper? Which is also of n by 2 plus 1, of n by 2 plus 1. So this is our space complexity. So remember, from brute force we are getting of n square as a time complexity and space complexity of 1. And for this hashing approach, we can say this is a hashing, and here we are getting time complexity as a of n and space complexity of n by 2 at worst case. So this is the optimal solution for this question. There is a one more solution which is best for this question, in which the time complexity will be of n, but there the space complexity will also be of 1 only, and that is one algorithm known as Murray voting algorithm. Murray voting algorithm. So we can solve this question using this algorithm, where it took off an as a time complexity and off one as a space complexity. So we will discuss this algorithm and later, and then we will solve this question with this algorithm as well. So this is the explanation for this question. Lead code number 169, majority element. Now let's code it. So what we discuss. So first we will code the brute force for int. First what we required, first we check, we get the size of the array, nums dot size. Now we will start our I equal to 0 to n I plus plus. Now here what is our number? So int number is equal to nums of y. We will check this number with all the future numbers. Now what is our count? Equal to 1. Why 1? Because we are taking at least this number. Now we will start our second pointer, which is start from I plus 1 and it will goes to n. Now if nums of j equal to number, then we will increase our count, otherwise we will do nothing. Once we check all the numbers and we will get the occurrence of nums of I, then we will see if count is greater than n by 2. If count is greater than n by 2, then we will easily return number as our answer. If it does not, it will iterate for the another number. And here, if we will not get anything, then we will return -1. So let's test the example test cases. Yeah, so it passed all the example test cases. Now let me submit it. So yeah, our test case has been submitted. Now what is the time complexity we discussed for this solution of n into n, n for this loop and second n for this loop. Now let's do the brute force approach where we need mapper. So we write unordered map with integer mapper. Now we will get the frequency of each number. So int I equal to 0, I less than n, and I plus plus. If mapper dot find nums of I, if it is already present, then we will just increase the frequency of that number plus plus. If it is not, then we will initialize it with 1, nums of I equals to 1. So after this loop we will have our mapper which contain all the frequency. Now we will iterate the mappers. So we will iterate the auto it mapper. If, and what is the first element? The first element it dot first is our number and it dot second is our frequency, or we are using as a count, so count of occurrence. Okay, if count of occurrence is greater than n by 2, then we will return number as our answer. If not, then we will iterate another, we will go for another number, and at the end, if we not found the majority element, we will return -1. But this will not execute in our case, because if we see the description, it clearly says you may assume majority element always exists in array. So this will not trigger execute in this code. So what is our n? N is nums dot size. Now let's run this code as well. Yeah, so it is also passed our test example test cases. Now submit it. Yeah, so this code is also executed successfully. And what is the time complexity we discussed for this solution? Of n for this and of n k. Of k, what is k? The different digit, the different and unique digits. And space complexity we discussed as a mapper. We are using mapper which require some space to store the frequency of each element. So that is also O of k as a space complexity. So that's it, guys. If you like the tutorial and if you have any feedback, please write it in the comment section, and please like and share the video. Thank you.